Hello everyone, myself Sharmila Rothia. Today we will discuss about Fraunhoffer diffraction at N-slit. When a large number of identical narrow rectangular slits are held parallel to each other, having same separation by an opaque space is called grating. Now suppose a plane transmission grating consists of n parallel slits, each of width small a, and separated by a distance small b. And let a plane wavefront of light from a monochromatic source of light having wavelength lambda be incident normally on the grating. Now according to Huygens Fresnel assumption, every point on each slit act as a source of secondary wavelets in all the directions, and a convex lens L is used to make them converge on the screen at point O. But when rays are diffracted by an angle theta with respect to the incident rays, after passing through the convex lens L, they reach at point Q. Now using the Fraunhofer diffraction at a single slit, the secondary wave from all the points in a slit diffracted at angle theta are equivalent to a single wave having the amplitude A naught A naught sine alpha by alpha. We know this is the amplitude due to the single slit. In this case, suppose these are n slits. Okay, we have studied single slit, then double slit, and now n slit. In case of double slit, we can assume that two individual slit. The effect is like as two individual slit. Only difference is that there is a because of coherent two slit act as an coherent source, there is a interference pattern also. The new thing is only interference pattern. The diffraction phenomena and amplitude or maxima minima conditions all are same as in case of single slit. So in case of n slit, there is a combination of single slit and double slit phenomena. Okay, both are combined in this case. In this case, we consider all the rays coming from the single slit as suppose this is y1. Y1 is the resultant of all the rays coming from this slit. This is the resultant wave vector of all the rays coming from this slit S1, suppose. Okay, and suppose y2 is the resultant wave vector of all the rays coming from the slit S2. This is the resultant wave vector, all the rays coming from this. Okay, this is y3, this is y4, and so on. And now we have to find the effective amplitude or intensity resultant of all these waves at any point. Okay, and suppose resultant of all these wave is y. Okay, so in this case the diffraction is also from the single slit as in case of double slit. Okay, and if two slits are involved, then there is interference pattern. Suppose small a is the width of slit and small b is separation between two slit. Then any point having a distance of a plus b, any two points having a separation of a plus b, these are known as corresponding points. And as same in case of double slit, and the two rays coming from the corresponding points, they interfere. Okay, the fringe is due to interference. And because the original source is same, single, okay, suppose S is the source of monochromatic light, then all rays coming from all these slits have same amplitude. Suppose A, okay, and in the previous case we have studied A is the effective amplitude due to all the rays coming from a single slit. A is the effective amplitude rays coming from single slit. Okay, so amplitude of this is also A. Okay, and we have to find this resultant amplitude. Suppose this is A dash. We have to find this amplitude now. And phase difference due to single slit. Phase difference due to single slit was alpha. Okay, single slit, phase difference due to single slit was alpha. All will create alpha phase difference individually. And phase difference between the rays from two conjunctive slits, that was 2 beta. Okay, sorry, this was 2 alpha. Okay, the phase difference created by single slit was 2 alpha, and phase difference created by 2 conjunctive slit was 2 beta. The rays coming from 2 corresponding points, the phase difference is 2 beta. And if we are going from first slit to nth slit, the phase difference going on increasing. Okay, if these two slits create a phase difference of 2 beta, then phase difference between the rays from first and third slit will be 4 beta. Okay, phase difference between first and third slit is 4 beta, and first and fourth slit will be 6 beta, and so on. Phase difference is going on increasing as we go from first to nth slit. And we have alpha is equal to pi by lambda A sin theta. Alpha is the phase difference due to single slit. Okay, so this is, and beta is equal to pi by lambda A plus B sin theta. This is beta. Okay, and path difference corresponding to this phase difference, path difference was A sin theta, and corresponding to this phase difference, path difference was A plus B sin theta. Now we have to find the A dash, resultant amplitude of the due to all rays coming from the N slit. This is the same case as in we studied in single slit. We consider the slit AB is divided into small elements, n number of elements, and we write the wave vector for all the rays coming from all the elements. Okay, then we find resultant from all this wave. So by using similar to this to that equation, we can write A dash will be A sin theta, A sin n phi by 2 divided by sin phi by 2. Okay, and we know A is equal to, A is what? A naught sin alpha by alpha. Okay, and in this case phi is equal to, phi is what? This is the phase, this should be the phase difference between the two conjunctive slit. Okay, in that case of single slit, we write the phase difference between the rays coming from two adjacent elements, that was phi. In that case, phi was phase difference between the two rays coming from two conjunctive elements. So in this case, phi Phi should be the phase difference between the rays coming from two conjunctive slit, and we know this phase difference between the rays coming from two conjunctive slit is 2 beta. Okay, this is equal to 2 beta. So phi is equal to 2 beta, and we know 2 beta is equal to 2 pi by lambda a plus b sine theta. Okay, now putting the value of phi, we have a dash is equal to, and also the value of a. Value of a is a naught sine alpha by alpha. This is the value of a. And now putting the value of phi, sine n, phi is 2 beta. Okay, divided by 2. And sine phi is 2 beta. Okay, now 2 cancel out. Finally we have a dash is equal to a naught sine alpha by alpha into sine n beta. Okay, and divided by sine beta. This is the effective amplitude due to all the rays from N slits. This is amplitude, and I intensity. What is intensity? A dash square. Okay, so we can write a naught square sine square alpha by alpha square into sine square n beta divided by sine square beta. So this is the resultant intensity. Okay, resultant intensity at any point Q, and the central point is equidistant. Okay, a central point is again bright in this case also, and this is the intensity at any point Q, which is away from center O. Now this is maximum intensity. This is the amplitude of the rays which are going without diffraction. Okay, and intensity corresponding to this is I naughts, or a naught square. This is I naught. Okay. Now if we have n is equal to 1 and there are n number of slit, this n represent the n number of n represent the number of slit. If n is equal to 1, n is equal to 1 is single slit, then this n is equal to 1. This is cancel out, and we finally got intensity is equal to this, and this is the intensity due to single slit. Okay, if n is equal to 2, then this is equal to 2 beta. Okay, this is 2 beta and sine square 2 beta. Okay, and we know we can write this sine 2 beta is equal to 2 sine beta cos beta. Okay, and square of this, or we can write this as 4 sine square beta cos square beta. Okay, and divided by this sine square beta. This sine square beta would be cancel out, and we finally got this is I is equal to 4I naught sine square alpha by alpha square into cos square beta. If n is equal to 2, then we have intensity I is equal to this, and this is the same as in case of double slit. This is the intensity due to double slit. So this is the intensity due to N-slit. This is due to this term is due to single slit, and only this is due to N-slit. This term gives the contribution of N-slit. Okay, this term gives the diffraction pattern due to N-slit. Now suppose sine square n beta by sine square beta is equal to z. We consider only this term because this will give the effect of N-slit diffraction. Okay, now to find the maxima and minima, we have to find the slope, or we have to differentiate this. Okay, we have to find the dz by d beta. We have to differentiate this equation with respect to beta. Now by differentiating z with respect to beta, we got this equation. Now we have to solve this, taking common sine beta. 2 sine beta is common. Okay, 2 sine beta this is 2 sine beta. Sine n beta is also common. Sine n beta, and inside the bracket the remaining terms are sine beta now by taking common sine 2 sine beta and sine n beta, we got this equation, and this will be cancelled out. Third 3 power. Okay, this is cancelled out, so remaining term is this. Again putting out this outside the bracket, sine n beta, we have 2 sine n beta, sine n beta. Okay, by multiplying 1 sine beta inside, 1 by sine beta, we have sine n beta by sine square beta. Okay, then we have if we are sine beta, then this is cancel out, this sine beta is cancelled out by this. The remaining term is n cos n beta, and this is sine n beta, sine n beta, and this is cot beta into cot beta. Okay, again multiply and divided by sine n beta. We have, by multiplying this sine n beta, we have sine square n beta divided by sine square beta. Okay, and divided inside n cos n beta divided by sine n beta minus sine n beta into cot beta divided by sine n beta. Okay, this is cancel out. So finally we have 2 sine square n beta by sine square beta. This is n cot n beta minus cot beta. This equation represents the differentiation of the z with respect to beta. Now for finding the maxima or minima, we have equating this equation 0. We have to equate this equation to 0. Okay, either this term is equal to 0 or this is equal to 0, but this term can't be equal to 0. Okay, this can't be equal to 0, then this must be equal to 0. And 2 sine square n beta by sine square beta is equal to 0, or this is equal to 0. Now the condition for the central maxima or principal maxima, we have if sine n beta is equal to 0, for the value if sine beta is equal to 0, okay, if sine beta is equal to 0, then beta is odd. This is beta is equal to plus minus n pi. For beta is equal to plus minus n pi, sine beta is equal to 0. And for beta is equal to plus minus n pi, this term is also equal to 0. So we have this is 0 by 0 terms, which is indeterminate. So we have to apply L'Hospital rule. By applying L'Hospital rule, beta tending to plus minus n pi sine n beta. Sorry, this is sine n beta by this is sine beta. We have to differentiate numerator and denominator with respect to beta. So by differentiating this with respect to beta, we have cos n beta into n. Similarly here cos beta. This is so now for the value of beta is equal to plus minus n pi, we have this is equal to plus minus n. By putting the value of beta plus minus 1 in this value, in this equation, we have plus minus n. Now the resultant intensity for maxima will be I is equal to n square a naught square or sine square alpha by alpha square. This would be the resultant intensity. Okay, where alpha is equal to pi by lambda a sine theta. Okay, and beta is equal to plus minus n pi gives the value of principal maxima, or beta is equal to pi by lambda a plus b sine theta. Okay, pi to pi cancel out, and we have a plus b sine theta is equal to plus minus n lambda. Okay, so this is the condition for principal maxima. N is equal to 0, plus minus 1, plus minus 2, and so on. N is equal to 0 corresponding represents the central maxima. Central maxima is the brightest maxima. Okay, and after that, if we are putting n is equal to plus minus 1, n corresponding to plus minus 1 gives the value of principal maxima, first principal. This is n equal to 0 is central maxima. This will give the first principal maxima, second principal maxima, and so on. Now we have to find the secondary maxima and minima. Now if sin n beta, if sin n beta is equal to 0, but sin beta is not equal to 0, then intensity will be minimum. The resultant intensity is given by this equation. Okay, and here sin n beta is equal to 0. This is equal to 0, but this is not equal to 0. Okay, if this is also 0, then the term is indeterminate. We have discussed earlier. So in this case, if this is equal to 0, whole term represents 0, means I is equal to 0. I 0 means minima. So if sin n beta is equal to 0 and sin beta is not equal to 0, then this is the condition for minima. Okay. And in this case, we have if this equation is satisfied, then beta is equal to plus minus n beta. Okay, n beta is equal to plus minus n pi, and from here beta is equal to plus minus n pi by n. Okay, this is beta, and we know beta is equal to a plus b sin theta. Okay, into pi by lambda. Beta is equal to pi by lambda a plus b sin theta, and from here beta is plus minus n pi by capital N. Pi to pi cancel out, and we have a plus b sin theta is equal to plus minus n lambda by n. This is the condition for minimum. Okay, again here n is equal to 0, 1, 2, 3. Okay, natural number. But if n is equal to small n is equal to capital N, then if this is equal to this, then we have is equal to this. If n is equal to small n is equal to n, 2n, 3n, and so on. In this case, we have this equation is equal to part difference is equal to 1 lambda plus minus 1 lambda plus minus 2 lambda plus minus 3 lambda. But we know this is the condition for principal maxima. For principal maxima, beta is equal to plus minus n pi, and part difference is equal to a plus b sin theta is equal to n lambda. Okay, here the same condition is not applicable for minima and maxima simultaneously. Okay, so in this case n cannot be equal to this. Okay, suppose n is equal to 3. Okay, if n is equal to 3, then small n, in this case small n can never be 3, 6, 9, 12, and so on. Means n, 2n, 3n and so on. Okay, n can never be equal to these values. So n can accommodate what values? N is equal to 1, 2. These are the condition for positions of minima. So at 1 and 2, these are minima. Then 3, this is principal maxima. Again 6 and 4 and 5 are condition for minima. Again 6 is condition for maxima. So we can say between two conjunctive principal maxima, there are n minus 1 minima. Here n is 3, so there are 2 minima. 3 minus 1, 2 minima. Okay, we can say in this case between the two principal maxima there is n minus 1 minima. So intensity distribution for N-slit can be seen in this figure. We can see clearly the central maxima is surrounded by minima, n minus 1 minima. So there are n minus 1 minima between two conjunctive principal maxima. Now the absent spectra in diffraction grating. There are also some spectra are missing as in case of double slit. Okay. Again for n parallel slit, the condition for nth order principal maxima is a plus b. This is a plus b is equal to this. Okay. For nth order principal maxima, this is the condition for principal maxima. It means for the value of angle of diffraction theta satisfying the above equation, we have the principal maximum. But sometimes we do not have it, because if the path difference between the diffracted rays from two extreme points of the slit is lambda, if two extreme point rays from two extreme point of a single slit is lambda, that is a sine theta is equal to lambda. If for the same value of theta we have a sine theta is equal to lambda, and for the same value of theta we have this condition also satisfied. Okay, then this is the condition for maxima for interfering rays. Okay, in case of interference, this is the condition for maxima, and this is the condition for minima due to diffraction, diffracted rays. For diffracted rays, this is condition for minima, and this is condition for maxima for interfering rays. So for the same value of theta, both equations are satisfied. In that case, the principal maxima of nth order will be absent. Principal maxima. Okay, principal maxima of nth order will be absent. Now from these two equations, equation of maxima for interfering and equation of minima for diffracted rays, we have a plus b by a is equal to n by m. Okay, suppose a plus b sine theta is equal to n lambda. This is the condition for maxima. Okay, and a sine theta is equal to m lambda. This is condition for minima. Okay, so if a and b are equal, width of the slit is equal to the separation between two slits, we have n is equal to 2m. Okay, m is equal to 1, 2, 3 and so on. So from here we can see that second, 4th, 6th order of the spectra will be missing. For n is equal to 1, 2, 3, n is equal to 2, 4, 6, 8 and so on. these spectra are missing. In this lecture, we have studied the Fraunhofer diffraction at N-slit, or we can say grating. So here are some basic questions from this lectures. Question 1. What is grating? You have to define grating. The next question is, what do you mean by grating element? The next question is, find the position of principal maxima for Fraunhofer diffraction due to N-slit. The next question is, find the positions of secondary maxima and minima for Fraunhofer diffraction due to N-slit. The next question is, discuss the absent spectra in diffraction grating. The next question is, in plane transmission grating, the angle of diffraction for second order maxima for wavelength 5 into 10 to the power minus 5 centimeter is 30 degree. Then calculate the number of lines in 1 centimeter of grating area. In this question, you have to calculate the number of lines of grating of per centimeter. The next question is, describe the action of plane transmission grating. In this question, you have to describe how the grating works. Okay. The next question is, the tracks of a compact disc act as a diffraction grating, producing the separation of the colors of white light. Option A, it's true. Option B, it's false. You have to choose the correct option for this question.